Okay, let's unpack this. Imagine uh, peering back to the very moment stars are born, or, witnessing distant galaxies collide, maybe even seeing the edge of a black hole for the first time. Our deep dive today takes us to, well, one of the most extreme places on Earth, high up in the northern Chilean Andes. We're talking about the Atacama Desert, home to the Atacama Large Millimeter submillimeter Array, or ALMA. This is where some really profound cosmic insights are being uncovered.
Right. And what's truly fascinating about LMA is that it's not just one single giant telescope. It's actually an astronomical interferometer. Think of it as a network of 66 incredibly precise radio antennas. They all work together in unison, basically acting like one colossal virtual telescope.
56 of them, wow.
Yeah, and it's strategically placed on the Chajnantor Plateau at this breathtaking altitude of 5,000 meters. That's about 16,000 feet above sea level.
That's incredibly high, isn't it?
It is. And that extreme elevation, plus the desert's incredibly low humidity, well, that combination is absolutely crucial. It significantly cuts down on what we call signal attenuation, basically the Earth's atmosphere weakening or scattering those cosmic signals.
Ah, I see. So the height and dryness give a clearer view.
Exactly. It allows for crystal clear observations in these millimeter and submillimeter wavelengths, and those are essential for peering through all the dust and gas that usually block visible light.
That's quite a feat, just finding it using a location like that. But tell me, what does it take to build something on this scale? With that kind of precision, I understand it came with a pretty hefty price tag, too. Made it the most expensive ground-based telescope ever built, correct?
You're absolutely right about the cost. It was staggering, around $1.4 billion. But, beyond the money, what's truly remarkable is its sheer adaptability. These antennas, some are huge, like 12 meters across. They aren't fixed in place.
They can move them.
Yes, precisely. They can be moved across the desert plateau over distances from just 150 meters apart, all the way up to 16 kilometers.
16 kilometers, that's huge.
It is. Imagine changing the focus on a camera lens, but just on this massive scale. It gives ALMA this unparalleled variable zoom capability. So astronomers can fine-tune its resolution. They can either see a broad cosmic picture or zoom in for incredible detail on a tiny patch of sky.
That variable zoom?
Yeah.
That sounds like a real game changer. And it really is a global effort, isn't it? Lots of countries involved.
Absolutely. It's a fantastic testament to international collaboration. You've got major partners like Europe, the U.S., Canada, Japan, South Korea, Taiwan, all working alongside Chile, of course.
Mm-hmm.
This kind of collaborative spirit is just fundamental for tackling such ambitious science. And if you connect this to the bigger picture, ALMA has given us just unparalleled insights into star birth back in the early universe. It gives us a clearer view of how stars and planets actually form than we ever had before.
Like specific examples.
Yeah. Oh, definitely. For instance, it produced the sharpest ever submillimeter image of the colliding antenna galaxies. It revealed these massive clouds of dense, cold gas, the actual nurseries where new stars are forming right now, stuff completely invisible to optical telescopes.
Right, because the dust gets in the way for visible light.
Exactly. But LMA sees right through it.
And the discoveries just keep getting more surprising, don't they? I remember hearing about one particular image that really shook things up, redefined our understanding of planet formation.
You're probably thinking of LMA's amazing image of the protoplanetary disk around a very young star, HL Tauri. And that wasn't just, a pretty picture. It was a real bombshell. It completely revised our timeline for how planets form.
How so?
Well, the image showed these clear, concentric, bright rings separated by gaps. And those are telltale signs of planets actively forming. But the kicker was, this system was only maybe 100,000 to 1,000,000 years old.
That young, wow.
Yeah. Before ALMA, we generally thought it took tens of millions of years for planets to really start getting going. This observation just, boom, dramatically sped up that whole assumed timeline.
That's a huge leap in understanding. Just incredible. And speaking of these groundbreaking observations, ALMA's role goes even further, doesn't it? It was a key player in another historic scientific achievement recently.
Indeed it was. ALMA was a crucial participant in the Event Horizon Telescope project. Its sensitivity and its unique location made it an absolutely invaluable part of that global network of telescopes, the one that collectively created the very first direct image of a black hole, the one published back in 2019.
The famous M87 black hole image.
That's the one. ALMA's data was absolutely critical in piecing together that unprecedented view.
Incredible. When you just think about the sheer scale of ALMA in that extreme environment,
Yeah.
what stands out to you about the human and logistical challenges? Building it, operating it. I mean, moving those gigantic antennas around, that must have been an enormous undertaking in itself.
Oh, it's truly mind-boggling. Just imagine trying to transport one of those 115-ton antennas from the base camp at 2,900 meters all the way up to the 5,000-meter observing site.
Or even just moving them around on the plateau itself, right?
Exactly. They actually had to build two custom-designed 28-wheel self-loading heavy haulers. These were gigantic machines, 10 meters wide, 20 meters long.
20 meters long, just for moving antennas.
Yep, specifically for this job. And get this, the drivers even needed onboard oxygen tanks because the air is so thin up there.
Wow. That really puts it in perspective.
It does. And, despite all the incredible planning and international cooperation, a project this huge isn't immune to earthly problems. It's faced challenges, everything from worker strikes, which you kind of expect on large projects, to even a cyber attack fairly recently.
On cyber attack, even on a telescope.
Yeah, it proves that even a cosmic observatory has to deal with very, very terrestrial problems sometimes.
So wrapping this up, what does this all really mean for us? ALMA isn't just, a pile of sophisticated equipment up on a mountain, it feels like a profound testament to global teamwork and human ingenuity, really. It's constantly pushing the limits of what we can see, what we can understand about our universe. One surprising discovery after another.
It really is, and it makes you think, doesn't it? What other fundamental secrets might the universe be holding on to, just waiting there, waiting for us to develop the right eyes, and maybe just as importantly, the global cooperation to finally see them?